Okay. Okay. Yeah, is my screen okay? Just a minute. Yeah. A last confirmation. Is my screen visible? Just anybody? Is my screen visible? Yes, sir. Okay, yeah. Thank you. Okay. Now, uh, from today onwards, they have made it like everyone should take it to their individual classrooms. Before starting this, I'll tell you now your individual attendance will be taken in my classroom itself, which is as told by the department that you should maintain a minimum attendance to qualify for your exams also. So, which is nothing but an quiz which I'll be taking in the class. Uh, there is no markings for the quiz as such, but make sure that you are loyal for your answers. Okay, don't do it for your friends or something like that. So, since first unit was taken by Ramesh sir, which was common for all the divisions. Second unit, I started it, but due to some other works, it was taken by Prashant sir also. So now we are into the third unit, okay, which is nothing but Unix processes. So before going there, what I want to say here is we studied Unix introduction, which Ramesh sir gave you about that. What I mean by Unix, how the Unix operating system looks like, what are the standards available there, what are the limit values already available in the Unix. All that we had studied in the introduction part. So after knowing what is a Unix operating system, how it behaves and all, now my next step or my next task was to understand how the files are arranged in Unix or which types of files are available in Unix and all. So for that, we studied the next chapter, that is Unix files, in which we studied about how the information is maintained in Unix operating system. And as we all know now, everything in Unix is in terms of files. There we studied about different types of files available in Unix, the regular files, the directory files, the device files, the FIFO files and all. So all these files are used or they are there in which Unix system is preserved in that way. Like everything in Unix is in terms of files. There is nothing beyond files over there. So that is what we studied. Then we studied about the file attributes, different file attributes which are available. Every file has on an average 7 attributes, which we can get it by ls minus l command, which gives you the user ID, the group ID, the file link, the last access mode, sorry, the LMT, last modification time, and the file name, right? So all this we studied under the file attributes, which usually tells me like which all different attributes are available in the files. So after that, we studied about the inode in file. Like inode was nothing but an unique number, which a file is given when it is created, and it is given by the kernel. And that also we can get it by the command ls minus I. Minus I indicates the information for inode. Then we started about Unix kernel support for files, which Prashant sir took it because I was on leave for those 2 days. How you usually we double click on a file. The minute you double click on a file and the file gets opened, what process goes at the back end is nothing but kernel support for files. That is how kernel supports for opening of a file. And in the same way, the minute you click on the X button for closing, how exactly it responds for closing of a file. That is what we studied in Unix kernel support for files. Then we talked about the file and record locking, right? So that was all about how the things are maintained in Unix operating system. That was initially. We studied with the introduction part. Now I know what is a Unix operating system, what are the limits, what are the functions, FIPS standards, all that I know now. After that, again I understood like how the things are maintained in Unix. Everything is maintained in terms of files now. So files are there. Now the next task. Now once I know the files, the next task for me is to understand, go one step beyond. Now what I mean by one step beyond is files I know now. Now what happens when a file is under execution? Yeah, what happens when a file is under execution is nothing but a process. We studied in very first sem. A file under execution is known as a process. So the next unit, that is the third unit, is nothing but Unix processes. So we studied introduction, then I studied the types of files. What are different types of files? Now let's understand what happens when the files are under execution in Unix. We always have seen that cc filename.c. We also give /a.out. What happens at the back end is what we'll be studying about. The next unit is nothing but Unix processes. So in this topic, we'll be covering the various aspects like introduction, the main function. Usually we know now, we write a C program in main itself, right? So how exactly memory is allocated to main, how the main process starts, from where the main process starts. All that we'll be studying under the introduction part. After that, we'll be studying about process termination. Very important from exam point of view also. What are the different ways of a process can terminate? Usually we have, right? Usually if it's my own laptop and all, I use it so politely. I'll close the button, I'll save and close, I'll wait till it close, then I shut down my system, right? But sometimes in the lab and all, you have seen, when it's usually time up and professor is not leaving you, and the minute he says now, okay, you can leave, you rarely shut down the systems, right? You just switch it off from the main, right? It's again nothing but a process is terminating. Do you understand that? That is what I mean process termination. So how process termination takes place in Unix? Which are the different ways of process termination? Usually asked in the exams also, what are the different ways of process terminations? Then we'll study about the command line arguments. Just a minute, somebody is getting into the classroom. Yeah, please make sure that you join the classroom with your git.edu ID, okay? So that it don't prompt me for admitting you. Okay. Then we'll study about command line arguments, which I've studied from my very first sem. Main has two command line arguments, ARGC and ARGV. What are those? How it can be used? We'll be studying about that. Then we'll be studying about environment list. Now, environment list is nothing but the ready-made commands or the ready-made stuffs or APIs which are already given for you in the system, which are pre-defined in your Unix operating system. Those are nothing but we call as environment list. Then very important, we'll study about memory layout of a C program. So till now we have done programming like anything. You wrote code in all platforms. Probably if you have written a C or C++ code, is nothing but you have written a program, right? You have always written a program, and have you ever thought how the memory is allocated for a C program? I don't think so, right? So in this concept also we'll be studying about when you write a C program. For a C program, the memory is given as a single source only. But what happens when you execute the program? That is Control F9, or if I say here /a.out, if you say compile cc filename.c, then /a.out. The minute you run the program, how the memory is allocated, which are the different parameters considered, is what we'll be studying under memory layout of a C program. And then we will see about shared libraries. Now, shared libraries are something like here. Rather than keeping the data at different sources, you can keep the common sources at one place and you can access the things from that. Usually I call it as a shared library. See, rather than having 4 library functions, right? For example, if you have stdio.h, conio.h, maths.h, and stdlib.h. So there are 4 header files available for you. So what will happen is, those are library functions, right? All they are available in the libraries. So what happens? The common code among all those 4, the common code among all the 4 header files is taken off and kept at one place, which I mean by a shared library. So then wasting the space at 4 different places, we keep only at a single place. How it is done, what are the parameters behind that is what we'll be studying under shared libraries. Then is the memory allocation. Now we studied in data structures, right? Malloc, calloc, and realloc, right? So the same functions are also available in Unix also. Whenever you want to allocate memory for a program at runtime, we use memory allocation techniques, that is malloc, calloc, and realloc. Then we'll be studying about the various environment variables. Which are the different environment variables are available for me? Usually I've seen, right? I work in home directory, you say, right? We say usually, right? I work in a home directory now. So how a home directory is allocated, how a path is allocated for you. Yes, all that we'll be studying under environment variables. There are predefined variables for you in the system. Just like a system configuration, I say, there are predefined elements for the system also, and that we call it as environment variables. Then we'll study very important two functions, that is set jump and long jump functions. We have studied about goto and label, right? Goto and label. Okay, coming back here. Can anybody tell me what is goto and label in the chat box? What do you mean by goto function in C? Can anybody? What do you mean by a goto function? We studied in C, right? Goto, label. What do you mean by that? I hope people are there in the classroom. Anybody can unmute and say me also. Yeah. What do you mean by a goto function? Changes flow of execution, Abhishek. In what sense you mean to say? Means you mean to say it jumps from one location to other location? Yes, but there is one constraint for goto function. What is that constraint? Yes, goto function, what it does, it jumps from one specific location to other specific location. It goes to the specific line of the code which we mentioned. Yes, Mansi, it is correct. We go to the specific line, but there is one constraint with goto function. Can anybody tell me what is that constraint? What is the constraint for a goto function? Very true. It changes the flow, it jumps from one line to another line wherever you specify the label, right? It directly goes and jumps to that label. But what is that constraint with goto function? There is one constraint with a goto function. What is that constraint? Anybody? Okay, I'll tell you. The constraint with goto function is it should be true. Yeah, goto, Varun, it is correct. Goto will not check any condition. It will not check any condition. It will directly jump to the label. So only it is called as unconditional branching statements. Goto statement is called as unconditional because we never check a condition. Directly we jump. But the constraint with goto function is it works within a function itself. It works within the same function itself. For example, if you write a goto and label in the main function, it will be working there itself. But if you write a goto in main and the label in some other function, something like this, if I say, I'll just show you here, okay? I'm just giving the introduction. So for example, I'll write main here. I'll say goto demo, if I say, okay? And I'll close this. I'll say here function as function. I'll write a function like this. And if I write here the label as demo, this will never work for me. Look at this part here, okay? What I mean to say is, whenever you are using goto and label, now this is a goto statement, and this is a label for me. That means goto demo. So whenever this comes, it directly jumps to demo. But this will not work in C. If at all you are talking about this, some statements here like this, and if I write the demo here, what happens is whenever the keyword goto comes, goto demo. So what it does here is it skips this line. These lines are skipped and directly it jumps here. So this is what a goto and label means, unconditional branching. But the only thing with goto and label is it should be specified within the function itself, either in the main function or a user defined function, both the statements. But if you do something like this, see, if you do like this, what I did here, I wrote goto statement in main and the label demo, I have defined it's in a different function. Now here it will not work. Here it will not work. Why it will not work? Because this is the constraint with goto statement. A goto function works within the scope of a function, but not outside the function. Getting this? What I mean by goto statement? If I say goto demo, which means that from here it should jump wherever you have defined the label demo. But since this label demo is given in a function, it will not jump because it is out of the scope. So this is what I mean by a go-to and label. So if that is a go-to and label, then to overcome the drawbacks of go-to and label, what are the drawbacks? Go-to and label works within the scope of a function. So same way we have set jump and long jump. So set jump and long jump functions are similar to go-to functions, but the only difference here is this can work outside the function, outside the scope of the function. That means you can define a set jump in one, that is set jump here acts as a label now. Set jump acts as a label and long jump acts as a go-to function. So you can define that something like go-to and label outside the function also. That means in the main function you can have set, and in the user-defined function you can have long jump. It is similar to go-to function itself, but only difference here is this can jump across the functions, but whereas goto will jump within the functions. Then we have get r limit and set r limit. Now we know now get r limit and set r limit. See, the minute you try to buy a new mobile phone or something, you go and check its phone, right? The system settings, how much is the RAM, how much is the processor, right? All those we check it. So what are those? Those are the resources of your mobile phone. What's the RAM, what's the bandwidth, what's the memory, what's the processor, all that you check it, right? So that, what are those? Those are the resources which are given for you on your mobile phone. Similarly, in Unix also, you have different resources given to you. Which are the different resources available in Unix? How to get those resources? How can you modify those resources? Because every resource has a limit given to you. Still you can modify the resources, till you can set the resources and all. So all that you will be studying under get r limit and set r limit functions. And the last one is kernel support for processes. Now in the previous chapter we said about how kernel supports for opening and closing of file. We did that. But now my next task is to understand how Unix kernel support for processes. That means when your program is running, when your program is under run mode, what happens at the backend? Is that we'll be studying under Unix kernel support for processes. So this is the overall introduction about this chapter. It all deals with processing part. Now my code is there with me, files are there. Now all those code and files which are in the run mode is what nothing but a process. So how these processes are tackled, how a process can see. Usually you write a C program, it goes in infinite loop. Do you wait till the program terminates? We never do that. So you have to wait for years for your program to terminate then, right? But what you do, you press break key from your keyboard, or else you press Ctrl Z key from your keyboard. Chalo, forget that. Very simple example. You are trying to start an application and it shows that Windows is not responding. You get something like a round notation circle. So you wait till that it completes? No. I just press Alt Control Delete, right? I want to break the process or terminate the process. So that is what is nothing but a process termination. Now there are various ways how a process can terminate and all. That is all we'll be studying under this unit. So is the introduction clear about the third chapter? What are we studying here? Is the overview clear in the chat box? Anybody for me again? This is just, I want you to keep active here, okay? See your chat box, we are recording this session and your chat box is also recording. That is again a secondary proof for me saying that these people are present for me, okay? Yes, okay, yeah, thank you. So this was the overview about the third chapter, okay? Yes. Yeah, thank you. Okay, fine, no issues. Okay, we'll go back. Okay, this was the introduction about the third chapter. Now we'll start the very first. So as we all know now, the unit this is unit 3, okay? I just have it's unit 3. Everywhere I just make it unit 4, it's unit 3. So here what we'll be studying is a process. Now a process is nothing but, as we all know, a program under execution. So when a program is there and when it is in execute mode, we call it as a process. So this is what all about this unit is all about. Now you can understand that there are n number of files available in Unix. Now those files are in the run mode. Then they become a process. Very simple as what I can say now. There are n number of files available in Unix. So all those files, when they are in running mode, I call it as a process. So the very first thing what we'll be studying here is the main function. Now we all know whenever a C program starts its execution, it starts from the main function itself, right? So whenever a C program is starting from a main function, what happens here is, now I'll just demonstrate it with the help of a paint here, okay? Okay, so see, when I say a C program, what happens here is, now this is the memory given for you, right? These are the memory blocks. Assume that these are the memory blocks given for you, the main memory. Okay, this is the memory block, how it is arranged. So when you run a program, so what happens here is, when you run a program, your kernel has to allocate memory for it, right? The kernel has to allocate memory. So whenever you start a C program, before the C program starts, what does the kernel do is, kernel starts a new routine, and that routine we call it as a startup routine. Okay, what does the kernel do initially is, whenever you execute a C program, before allocating the memory here, now since this is what I'm talking about, the memory. So what does the kernel do is, whenever you start a C program, the kernel foremost, it first executes a startup routine. Now what is the task of a startup routine is, whenever you execute a C program, whenever you execute a C program, the main task of a startup routine is to allocate the base memory from where the program should start execution. So whenever you write a C program, now I know C program starts execution from main. C program starts its execution from, sorry for that, okay, from main. Okay, I know this. C program starts its execution from main. But before it starts, it should be given some memory from where it should start execution. So what does your kernel does is, it runs a startup routine. We usually call it as a bootstrap loader. Okay, we call it as a bootstrap loader, which comes in system software. Now I don't have to think about what is system software initially. See, kernel starts a startup routine, and what is the task of this startup routine is to allocate memory. So the startup routine may come here, the first memory block, it sees whether this memory is free. If yes, then allocate this memory to C program. If not, then again the startup routine comes here, checks here. If the memory is free, again allocate this memory to the C program. Now this is nothing but the starting location from where your C program will start execution. Like this, there are n number of memory blocks available from you. So what does the kernel do is, whenever you run a C program, the task of a kernel is to first run a startup routine. The task of a startup routine is to allocate the starting address for a C program. Like from which address your C program should start running. Because see, when you're running a C program, memory has to be allocated. Now who will allocate the memory, and how the memory is allocated? The memory is allocated by the kernel. Kernel does this with the help of a startup routine. Once the C program starts, kernel calls a startup routine. We call it as a bootstrap loader. The task of this is to check each memory block. If the memory is free, it allocates the starting memory. It allocates the starting memory. It allocates the starting memory, and from that location, your C program will start executing. If not this, so next time when you start the program again, maybe the startup routine may take the memory from the different block. If not, it may take it from this block, or it may take it from this block. So whenever you run, each time you run a C program, the startup routine runs and allocates starting memory for the code. That is what is told here for you now. See here, when I said a C program starts execution with a function called main, right? So when a C program is executed, see here, look at this statement, okay, which I'm highlighting. When a C program is executed by the kernel, by one of its exe functions, that is the execute functions, a special startup routine is called before the main function is called. That means when you think that you are running a C program, but before that, kernel executes a different function. Kernel executes a different function, and that function is called as a startup routine. So what is the task of that startup routine? To allocate the starting address for the program. See a simple example when I'm talking about this. Whenever you come, right, every day you come to class, the first and the foremost thing is you go and reserve a bench. So you sit on the bench and your class starts. right? So today you came, maybe you have allocated yourself a seat on the first bench. So this is a startup routine. Before your class starts, you came and you sat on the first bench. So this is the startup routine which is running for you initially. You sat on the first bench, then your classes started. So next day when you come, maybe you may not get this first bench again. You may get a separate bench again, a third bench or fourth bench or some other row. So what is this? What I mean to say here is, whenever you run a C program, your C program will not always start from the same memory location. Every time it will get a different memory location from where it will start its processing. And that processing is given by a startup routine. See the same example. In school, we had our benches allocated for us, right? For the entire year, I was supposed to be sit on the same bench with the same bench partner, right? But now here it is nothing like that. Yeah, you come to college, the very first, see, it's a startup routine. Before the class starts, you are having your own startup routine. You come, you sit on a bench. Okay, that is the location where you are sitting and you are grasping the knowledge. Okay, today you sat on the first bench. Fine. So tomorrow when you come, here there is nothing concept of seat reserved and all. So tomorrow when you come, maybe somebody else is sitting on that bench. Now what is your task? To change the bench. So you'll sit on some other bench and you grasp the knowledge. Relate this to the C program also, I need to say. So before your program starts executing, there is a startup routine which is run by the kernel. Now what does the kernel do? Kernel runs the startup routine and allocates a memory location from where it should start executing its program. That is what I said here. When a C program is executed by the kernel, a special startup routine is called before the main function is called. So what is that task? What is that startup routine task? It starts is to assign a starting address for the program. That is, from which memory location your program should start executing from. From which memory location your program should start executing for you. And then this is sent to the editor where it is invoked by the compiler. So then your program will start executing. Please remember that. The minute I press .cc filename.c and /a.out, I get the output within no time on the screen. But this is what happens with the backend. The minute you run, kernel will start a startup routine we call as a main function, bootstrap loader. The task of that is to allocate memory to the C program, that is starting address. And please remember, every time the address is not same. The address may change every time, just like you come and sit in the class. You don't sit every day on the same bench for the entire semester, right? You keep on changing it. That's what's happening here also. Memories is not fixed for every C program. It keeps on changing. And what does the startup routine do now? It takes the values from the kernel. Now once you run, the startup routine will take the values from the kernel and your program starts executing. So from where it is, you have here, that is argc and argv. Argc is nothing but the number of command and arguments, and argv is nothing but pointer to this argument. Is this clear now, everyone? Yes, Abhishek, it always happens in the RAM only. Quite obvious, right? Unless and until you save it, it initially goes in the RAM, then it goes in ROM. Yeah, clear with this now? The things we studied here is, please remember, whenever you run a C program, the first task is kernel runs a special routine before your program starts executing. Yeah, Varun, it's a stack or heap memory which will come later on, because when I said about memory allocation of C program, right, there I'll elaborate more on this. When you allocate, there's something like a physical address, all that. We'll study in that concept here. Initially, it is a heap only. It's a bunch of memory, where the memory is given in segments. What is the memory is in terms of a segment. So what it does is, it chooses one segment, and from that, it assigns the initial address, and your program starts executing from that. Okay, it is something like a heap memory only. It is a heap memory. It is a heap is nothing but a pool of memory. So from the pool of memory available, it chooses one segment. On one segment, it assigns a memory address, the starting location from where it should start, and from that location, your C program starts executing. So this is what we studied about a C program itself. Okay, yeah. This is what I know now. What happens with the main? Now next is process termination. When I say a process termination, very important also, there are usually 5 ways of process termination. See, just like I said that, if it is your own laptop or something, when the class gets over, what you do, you close each file, you refresh it twice, thrice, then you shut down it. And sometimes it says that some processes are running at the back end, you keep on waiting, right? You keep on waiting, then you say end the task, and then you shut down your machine. This always happens with your personal laptops or personal things. But when it is a college property, what usually you do? Just directly switch off the CPU, right? Switch off the last button. The person who is sitting at the corner, he just switches off the button and all the systems are shut down, right? It is nothing but again your processes are being terminated. Yes. So in the same way, when you run a C program also, the process termination is nothing but now you have a program which is running. So once the program completes, it should close also, right? The process should close also. So which are the different ways of process termination is what we'll be studying under the next concept. There are two ways, if I say in general terminologies, there is a normal termination and there is a abnormal termination. So in normal termination, there are three ways. The first way is return from main. There is a function known as calling exit, which we studied in programs also, right? The minute I specify an exit statement in a C program, at that point your program terminates. If the statement is executed, your program terminates at that point only. Exit. And there is something known as underscore exit, okay? There is something known as underscore exit. So what is that we'll study also with the diagram later on. And there is something known as abnormal termination. Now abnormal termination is something like which are not done by the user in a proper way. That is what I said, right? Your friend is waiting outside and you are in the lab doing program. You'll never think of saving the file also. Directly switch off the CPU and run away. Because sir or madam has told shut down your systems and keep the chairs properly. Yeah, you never shut down it properly. So what is happening? The program which was running is still again being terminated abnormally. Getting this? This is what I call as abnormal termination. And there is something known as terminated by the signals. Now, terminated by the signals is something like you yourself are forcing the signal to exit. So, which are the different signals available and all? We'll be studying with this. Okay. So this diagram will give a clear indication for you. Now, look at the diagram carefully. Okay, students. See here. Whenever you run a C program, the first and the foremost thing, as I said, the kernel, look at the pointer also, okay, which I'm pointing it. Whenever you run a C program, what happens is the kernel first executes a startup routine. What is the task of a startup routine? Startup routine allocate the starting address. So once the starting address is allocated by the startup routine, now the next task of startup routine is to call the main function. See, kernel is not calling the main function. Kernel is calling a startup routine. Now this startup routine in turn will call the main function. So you terminate your program from main itself. So from main function, you may again have a user-defined functions also written, right? So what happens here is, so whenever you execute a C program, the kernel calls a startup routine. This startup routine in turn will call a main function. Okay, and as I said, you know, always main has the concept known as return. So what is the return value here in main? Usually we write this. I'll just show you here. Okay, I write like this. You have seen many times. Main something printf statement, and then you write return 0. In the main function, we usually write this all time. Yeah, we do write this return 0 in main. So can anybody tell me what is this return? Where this return 0 writes? See, in C program, usually we have seen, or just my faculty told me to write return 0, so I wrote. Where is this return 0 writes? Whenever you write return 0 in a C program, where it writes? Anybody in the chat box for me? Whenever I main is writing Gangadhar. Main is writing return. So see this program, okay? What is happening is main is calling the return function. That means now main has to return to somebody. And whom it is returning now? Where main function is called. Who calls the main function? Or where it writes now? Abhishek. My question only you are asking me, right? Now main is writing the return. So where it is returning the value? A main function. In the main program, you have called the function as return 0. Now my next question is, where is that return for you returning? Anybody? Okay, the main function, whenever it writes return, it writes to the operating system. Please remember that whenever a return is called in main function, it writes to the operating system or nothing but the kernel. See here, as I told here, the kernel is calling, right? So whenever you write return 0 in main, what does it do is it writes your startup routine saying that I have come to this statement. This is what I am talking here, because we know C program executes line by line. So the minute it comes here, it means that the statements before this are executed correctly. And return 0 means now you tell kernel that the statements written above me are executed properly without any errors and all, and give the control to the operating system for its further execution. Okay, this is what it writes. So I told you now here, see, there are different ways. Return from main. So what does return from main do is, whenever you write a return keyword in a main function, it writes to the operating system saying that till now whatever the statements were executed were correctly and successfully. This is a way of normal termination. So from main you call return function, it writes your startup routine. Even from user defined function you say return. So in user defined function, whenever you say return, it writes to its calling function. We know that if return is written here in the UDF, it writes to its calling function. Now main has called this. Similarly, when you write return in the main, who has called this? Operating system has called this, or in short, kernel. So whenever you use the keyword return, it means that the statements about this are executed successfully without any intervention, and your process can terminate easily. So this is one way of normal execution, return from main. So whenever you write the return keyword in main, it means that you're writing back to the kernel, and that point only comes when your statements above it are successful. Getting it? Next one is calling exit, the exit function which we have studied. So see here, from the main function, the minute you call the exit function, something like this, which we had studied in C also. We write here, right? Exit 0. In main we have seen many times. Exit 0 we have written, or we have seen also something like that. This we wrote, if n is greater than 0, printf, something like this, no value, exit 0. Something like this we have written in some programs. Okay, if this is not executed, you display a value, no value, and exit there itself. Don't go for the further statements. So the minute you write exit, which means that terminate the program there itself, right? So same way here also. So the minute you call an exit function in the main or from the user defined function, what does it do is, it does not return directly to the kernel. What does the exit function do is, whenever you call an exit function, before writing to the kernel, the task of exit function is to call the exit handlers. That means before writing to the kernel, what it does, it calls exit handlers. What are the exit handlers? Those are nothing but which says that now the memory which is allocated, you free the memory. The resources which are allocated, you free the resources, and then you write to the kernel. The use of exit function is, so the minute I call the exit function here like this, it will not directly write to the main operating system. Before that, what it does is, whenever exit function is called, before writing to the kernel, what it does is, it does some cleanup processing. Now what I mean by cleanup processing, it calls some exit handlers, which tells me now the resources which are allocated to the C program, you release those resources. The memory which is allocated, you free the memory, then you write it to the kernel. Look at the arrows here, okay? So whenever I write exit function in the main, it calls exit function, but before writing to the kernel, it calls some exit handlers or startup and cleanup routines. Now what are the tasks of this? The exit handler task is to release the resources which are allocated to the program, release this, and you write it to the kernel. Similarly, some memory is allocated, you release those memory, clean up it, and then write to the kernel. So normal termination in which calling exit is, whenever exit function is called, before writing to the kernel, it does some cleanup processing, and after this cleanup processing, it writes the value to the kernel. But this is not the case with underscore exit. That is what I said, calling underscore exit. That is, whenever an underscore exit is called, it never does any cleanup processing for you. So in the main also, if you call a function like this, if I call exit, what it does some cleanup processing. What I mean by cleanup processing, clean the memory, it will release the resources, it will release the IO devices. So whenever you call exit, before writing to the kernel, it does some cleanup processing. What is the cleanup processing? It cleans the memory allocated to the program. It releases the resources which are allocated to the program. In turn, it also releases the IO devices, that is the input-output devices which were allocated to the program. So again, it is a normal termination, but it does some cleanup processing also. And what if I call underscore exit? The minute I call underscore exit, what it does is it's directly writes to the kernel without doing any cleanup processing. That's the difference between, it's underscore exit. This is what the difference between exit and underscore exit. When you call exit function, it does some cleanup processing, but when you call underscore exit, it does not do any cleanup processing. It directly writes to the kernel. And the memory is still buffered here. See here, the minute you call underscore exit, it will not do anything. It will directly write to the kernel. From the main also you can call underscore exit. If you write underscore exit from the main, see, from here directly it is coming to the kernel. From exit even also you can call underscore exit. From here also it is directly coming to the kernel. So this is the task difference between an exit and underscore exit. When I say exit before terminating the C program, it does some cleanup processing. The cleanup processing might be like releasing the resources, releasing the memory, releasing the IO devices connected to it. But when you call underscore exit, the function itself, it will not do any cleanup processing. It directly writes to the kernel. Okay, so this is what about normal termination. Return from main will write to the kernel saying that the statement executed above it are good enough, everything is allocated properly, and it writes it. So it's a normal way of terminating, saying the OS that yes, all the statements above me are executed successfully. Calling exit is the minute you call exit, your program terminates, we know that. But before terminating, what it does some cleanup processing, like releasing the memory, which was already, and releasing the IO devices. The similar opposite of that is underscore exit. So whenever an underscore exit is called, it will not do any cleanup processing. It directly writes to the kernel without doing any cleanup processing. So this is all about the normal termination. This will take in the next class. Okay, is this clear, everyone? No, it won't release resources. That is what I said, Abhishek. It directly writes to the kernel. Now kernel will release the resources later on. Exit will release the resources by itself. Underscore exit, kernel will release the resources. Is that clear? So is this clear? It is up to you whether you want to use your memory properly or you don't want to use your memory properly. Why it is used in the sense, how can I say, Abhishek? It's up to you, right? Whether you want to terminate your process properly, then go for release the resources and use underscore exit. If you don't want to release the memory, let the kernel take care, you use underscore exit. Right? Simple example, Abhishek. You have n number of apps open on your mobile phones, right? So before your mobile phone, you close the apps or you directly restart your mobile? I can do both ways also, Abhishek. You have 5-6 apps open on your mobile phone and you want to restart your mobile. So what you do? Two ways with you. Either you close all the apps, then restart the mobile, or directly you can restart your mobile also, right? If the apps are open and you're restarting your mobile, it's underscore exit. Now who is closing the apps for you? Your kernel is closing the apps for you, right? And if you want to restart, you yourself close the apps, you're using exit. Got it, Abhishek? Hope I'm clear. Yes, Abhishek, am I clear? Okay. Now I'll post the quiz link here. Please answer this quiz, okay? Which is nothing but your attendance record also. Abhishek, am I clear? Yes, that is what I give simple example. And something went wrong with mobile, you are directly restarting your mobile, which is underscore exit, because now you are allowing your operating system to close those apps. Yes, why it is used? It is up to you now whether you want to close the apps and directly. If at all you want to restart, you close the apps yourself. Close means you release the memory, RAM and all. Then you restart it. Exit and underscore exit. Okay. Thank you for the class, students. Next class will take it on the next schedule time. Now this is the only link, okay? Now every time I'll not post in the class that you join the class. Timetable is with you. You can always join the class there itself, okay? Thank you. Have a nice day. Please answer the quiz and I'll turn off the recording.